In a previous video, I introduced what vectors are and what properties they have. In this video, I'd like to introduce the three main mathematical operations we can do with vectors. These are the operations you'll see come up most frequently. And that's the addition of two vectors, that's subtraction of two vectors, and multiplying a vector by a scalar. As a quick review, remember vectors are used to represent things that have both magnitude or size and direction. The magnitude we will often write as the vector without the little arrow above it. That's the vector symbol. So we'll write it without that vector symbol. In this case, the a vector would be just a is its magnitude. And then the direction we often denote by some angle from an axis, in this case, the x-axis. We could, of course, also do it from the y-axis. By placing our vector in a set of coordinate axes, we also then can describe our vector using components of that vector in that set of coordinate axes. In this case, it would be the x component of the a vector and the y component of the a vector. One thing I want to remind you of is that vector components depend on the coordinate system. So how we define our coordinate axes will tell us what our vector components are. Also, remember that the formula to find those components will depend on how we define our angles. So we'll have to make heavy use of trigonometry and the Pythagorean theorem when we are looking for components, magnitudes, and directions. So with all that in mind, I'd now like to introduce how we can add and subtract two vectors. I'm going to introduce a couple of ways to add vectors. The first way is using pictures. This is good for when I just want a quick estimate of what my result would be. I can draw a quick picture and figure out what my result approximately should be. For any sort of precise calculation, it isn't a very good method. But it's when we get to forces and we're drawing free body diagrams, it'll be very useful. Now, the graphical method is straightforward. Let's suppose I have two vectors, A there in the green and B in the blue, and I want to know what their sum is. I can do two different methods for adding vectors graphically. The first method is called the tip to tail method, and it works as follows. I take my first vector, in this case A, and I draw it. And then at the tip of A, I start the tail of B, and I draw B. And then I go back to where I started. I started at the tail of A, and I want to end at the tip of B. So from the tail of A to the tip of B, I draw my vector A plus B, and that's my result. So you always draw your vector from where you started at the beginning of A to where you ended at the end of B. And that's the tip to tail method. The second graphical method I want to introduce is what is known as the parallelogram method. And to use the parallelogram method, students like it because it often is how we present vectors. It tends to be somewhat cumbersome, as I'll show you in a minute. But the parallelogram method is very useful. I can start by just drawing my two vectors so that they have the same origin. I want to draw them starting at the same place. And then what I'm going to do is I'm going to draw a parallelogram. So I draw the parallelogram by drawing a line parallel to B at the tip of A and parallel to A at the tip of B. So that's the size of my parallelogram. And then my result is the diagonal of my parallelogram from the origin. So if I start at the origin, I draw the diagonal, I get my result, A plus B. And so you can see that A plus B, whether I use the parallelogram method or I use the tip to tail method, I get the same result. They're both equivalent. What happens if I have more than one vector? Well, the tip to tail method is straightforward. I just add on a new vector. So if I had now A, B, and C, and I want to find out what A plus B plus C is, I start with A, just as I did before. At the tip of A, I draw B. just as I did before. And now at the tip of B, I draw C. And to find my result, to find the vector, that is A plus B plus C, I have to go back to where I started. I started at the beginning of A, and I draw to the end of C. And that's my vector, A plus B plus C. So that red line, that red arrow, is my vector, A plus B plus C. The parallelogram method, as I said, is a little bit cumbersome because there's no way to draw a parallelogram with 6 sides, right? That's not a parallelogram. So what I have to do is I have to use 2 vectors, pick any 2, find the result of those 2, and use that new resulting vector to find the to make the side of the parallelogram with a 3rd vector. So, for example, I take A and B, I draw the sides of my parallelogram, I find A plus B, and now A plus B gives me the sides of a parallelogram with C to find A plus B plus C. As you can see, if I have honestly more than 2 vectors, but I guess more than 3 vectors, this is going to get very cumbersome because I always have to find my intermediate results of my 2-vector sum. So the parallelogram method tends to be somewhat cumbersome to use in practice. The tip-to-tail method is nice and quick and dirty, and I can do it for as many vectors as I want. So that's the 2 methods I can use for adding vectors graphically. Now suppose I want, instead of knowing what A plus B is, I want to know what A minus B is. So how do I subtract 2 vectors? Well, we haven't talked about multiplication of a vector by a scalar, but you can imagine if I had the number, say 2, right? Well, if I drew that on the number line, there's 1, there's 2. And then, well, what is minus 2? Well, 2 then could be represented by an arrow from the origin to 2. If I wanted to have minus 2, well, I'd come in this negative direction, 1, 2, and I would get, now minus 2, I would get an arrow pointing in the opposite direction that is exactly the same length, just pointing in the opposite direction. So whenever I have a vector and I want to find out the negative of the vector, right, I just simply take my arrow and flip its direction. And then I can find A minus B by taking A plus minus B. So A plus minus B is the same as A minus B, and that gives me my result. So subtracting vectors graphically is also very straightforward. I just flip my direction of my 2nd vector and then add it to my 1st vector. I said before that the graphical method is good for getting us an estimate of our values. And actually, you can use it if you're very precise and you use a ruler and graph paper and some precision. You can actually find values. You can use it to do calculations, but it's fairly cumbersome to do. So to do most of our calculations, we will use what's known as the component method. Instead of taking our vectors and adding them up graphically and trying to find out, then measure what the length of that arrow is, what we'll do instead is take our vectors and put them in a coordinate system and find out what the components of those vectors are in the coordinate system. For example, we have the A and the B vector, and they're defined in this case by some angle relative to the x-axis. So there's a theta A and a theta B. We would use our trig to find out for the A vector what the x component of the A vector is and what the y component of the A vector is. And then we'd find out what the x component of the B vector is and what the y component of the B vector is. And we could write out our 2 vectors, A and B, in terms of those components. So the A vector is just its x component plus its y component summed vectorially. So, and B is similar. To find the sum of A plus B, we just add them. So a plus b is just its x components added up and its y components added up. Of course, the x components are both being multiplied, both have their scalar part times the unit vector, the x unit vector, the I hat. And so we can factor out that I hat and we just get an addition of their scalar components, ax plus bx, multiplied by the x direction. Similarly, in the y, we have the sum of the scalar components ay plus by times the y direction, j hat. And that gives us our result. So we can use this to get our components. And then, of course, we'd have to, if we wanted to know the magnitude of a plus b, we'd have to use Pythagorean theorem to take our components of a plus b and find the magnitude. Pictorially, what would this look like? What is this? What are we doing? Well, we said we can take a plus b, so we take the x components, ax, and the x components of b, bx, and we add them up. And the same we can do. We take the y component of b and the y component of a, and we add them up, and then we find the result. Right? So we find this result. That's a plus b, and you can see that it's exactly the same as we get from the graphical method. So we can add vectors graphically, or we can also add them by means of their components. And it is the component addition that we will use most frequently. So you should get in the habit and definitely get some practice in writing vectors in terms of their magnitude and angle, and then finding their components for a given coordinate system and adding them up using the coordinates, or subtracting them using the coordinates. The last thing I want to talk about is what happens when I multiply a vector by a scalar. And it does what you probably would expect it to. If, say, you walk 30 meters north, suppose you walked instead 3 times as far. How far would you walk? Well, of course, you take 3 times 30 meters north, and you end up walking 90 meters north. Not really surprising. In the same way, if we have the a vector, and we wanted to find out what 3a was, well, we would take a, we just draw it 3 times, and add them up, and we get 3a. Or in terms of its components, again, we can write a in terms of its x and y components in some coordinate system. In this case, I've picked up, down, vertical, and horizontal. Then if I multiply it by 3, well, I just have 3 times the x components and 3 times the y components. And so I just multiply each of those component parts by 3. I distribute my 3 across, and I get my result, 3a. So you've seen how to add vectors, subtract vectors, and multiply vectors by a number. I've given you a method to do it graphically so that you can get a quick estimate, and also by means of the components of a vector so that we can do more precise calculations. You'll definitely have to be well versed in your use of trigonometry and the Pythagorean theorem in order to do calculations using vectors. And the vectors, honestly, are the bread and butter of this course. They will come up over and over and over. We'll see them when we talk about velocities, displacements, positions, accelerations. We'll see them when we talk about forces, when we talk about momentum, when we talk about torque. All of these things are vectors, and so you really want to get a handle on how they operate, what you can do with them, what they don't do. There's one more thing that we'll be able to do with vectors, and that is we can multiply 2 vectors together. However, the way that you can multiply 2 vectors together is different, very different, from the way we multiply a number by a vector. But if you have any questions, come see me during office hours.